Welcome to My Ramblings. This topic is my book, Lighting Design. After I had finished up the internship and then got assigned a position within the public works, I really didn't I really wanted to learn the profession and stuff. And I thought NAFAC at their Southwest Division, most of the stuff I seen people do there was kind of high level and probably would have been smarter to try to find a spot there, but I wanted to make sure that my technical abilities were developed, enhanced and expanded on and stuff. And so I was working in the public works design and engineering department, and at first there wasn't a lot to do, and then I had taken my power system courses. I had switched my emphasis away from uh, the more electronic type stuff, we'll call it for now, to power systems. But like most electrical engineers, you take an awful lot of courses that involve electromagnetism, which is basically the interaction of electric fields and magnetic fields. And I got to turn down my TV. So my TV's turned down, and I looked up at some lights, and I guess after looking at them so many times, I started to wonder, hey, that's light, that's electromagnetic radiation. And don't get me started about how many people laugh at you when you tell them that light is electromagnetic radiation. Uh, it follows the laws of electromagnetism. That was sort of my premise. Okay, hey, does that, can you use the theories of electromagnetism to design lighting systems? Should follow, but can I confirm that light coming out of a light fixture, or a luminaire as it's actually called, follows the laws of electromagnetism? Couldn't think of any reason why not. So I started just kind of getting some standards. We had a standards database back then, and I was reading up on, I think it was the National Lighting Association. Let me grab the book. IES Lighting Handbook, Illuminating Engineering Society of North America. First, I picked out some rather technical standards, and um, just get some information about it. And I noticed that one of the standards had some calculations and some definitions, they were matching up with what we learned in electromagnetism. Obviously, the standards were geared towards lighting, um, and whereas university courses, well, some of the stuff we got in was pretty advanced, I guess. But it was more, it's more generally applied to, um, and so on and so forth. And so, what I really found out, though, as I began exploring these standards more in depth and more broadly, is that, well, lighting's a little bit more than the physics of electromagnetic radiation, or the electrical engineering of electromagnetic radiation, because for a lighting system in a building, it's to light tasks for human beings, and thus there's actually three components to lighting design. There is the physics, of electromagnetic radiation, or propagation, I should say. There's the physiology, um, how the human eye and the brain responds um, to lighting bouncing off of objects. Actually, we don't see the light as much as what we see is the light bouncing off of something. And there's also psychology. There's a psychological aspect to lighting design. Um, architects employ this to great extent. You can affect mood. You can create a relaxed atmosphere, say at home, or you can create, I don't want to say intense, more intense and unrelaxed, um, depending on the lighting systems you use. Like you want one in a hospital, perhaps they want a sense of urgency. Waiting rooms are probably, lit to be a little more relaxed, but hallways where doctors and nurses travel through, you know, you can actually have the lighting, so it's not meant to relax you, keep you moving or whatever. Um, but and so as I'm doing this, um, one of the senior engineers, this was before they moved us out closer to the supposed projects, he noticed that I was exploring the topic, and he actually gave me a lighting design handbook. It went back a few years, but the basic theory is still the same. They covered a lot of material. The fixtures that they referred to, the luminaires they referred to, were sort of out of date, but you could apply the same principles to a newer luminaire, a newer fixture. Um, it was old enough that they had good coverage of mercury vapor lamps, which sort of faded into the sidelines. Well, because things like fluorescent lighting and high intensity discharge lighting came out. LEDs hadn't yet come on the horizon, but surprisingly enough, you know, whether it's the result of LEDs, a fluorescent tube, or an incandescent bulb, or an HID bulb, it's still essentially light, just of varying wavelengths. And each type of fixture has its particular characteristics, and within each type of light source, you have a variety of ways to create various different wavelengths. To give you the warm light, which is relaxing, and the cold light, which is more institutional. Hey, um, in fact, I even wrote a series of tutorials. I've got one out there on the web. I sell one every now and then. Not lately, but I'm trying. Just too many things on my plate. I wanted to have the second in the series out there a couple of years ago, and maybe I'll find time the last quarter of this year to get that one. The tutorials are done. It's just a matter of formatting them to the presenter's standards and requirements. And it takes a little bit of work, and it's not something I want to jump in for 5 minutes. I want to go through and make sure it's done right. So anyway, so that was one of the advantages of having a senior engineer, junior engineer, and at the time, like me, a more junior, more junior engineer. I had a power system stuff and like that, but for some reason, that that didn't really seem to be the skills and stuff that I was going to be working on, and it's probably why I started looking around for other jobs. I didn't want to lose the capacity and the knowledge that I had gained from the internship and from my university studies. But this really kept me interested for a while, and I had one project out at one of the bases. One of the industrial facilities needed a wash station, so the mechanical engineers took care of the washing part, but I had to design the lighting for it. And that's kind of where the AMG theory came into place. So I wrote a spreadsheet. Because the light source is actually, I don't know, 9 inches, but the distance to the floor was like 12 feet. So since the general rule of thumb is, if a round lamp is 10 times its diameter from what you're trying to lit, you can assume it as a point source. So I use point source calculations to I set up a spreadsheet. Each point, okay, really involved complications. It's probably about as far as you could take a spreadsheet. We just didn't have any other software to use. And so each grid of what was to be lit would accumulate the light from each of the sources. And you had to use the point source calculations, which I think is a square. But the other thing you had to take into account is that light fixtures and luminaires, they don't radiate the same amount of light in every direction. So it might have this many lumens coming out at this angle, and this many lumens coming out at this angle, and so on and so forth. And so the calculations had to take that into account. This is the lumen distribution of the particular, there was only one fixture, so it simplified it a great deal. And so I actually had to go through and tabulate essentially the angles I was using. I don't remember if the equations interpolated or if I interpolated and put the values in the spreadsheet. I mean, geez, that was like, I don't know, 1995, 1996. And so what also helped is because usually when you have a light fixture, you usually have direct components and interreflection, which all the light bouncing on the walls, you have to add that up, and however, and whatever, so that you have an indirect component on the task and you have a direct component on the task. Well, I was able to use this spreadsheet because we had no walls. We had some posts holding up a ceiling, and so I didn't have to worry about the inner reflection. I just needed to compute the direct components of the lighting. So there you have it, one topic from my book. One of the things I intend, I'll probably put all of the lighting tutorials in the book, but I think there was 8 of them. 2 I still have to finish, but I'm not sure. I got to go back and look at those. Anyway, topic from my book, lighting design, or like they like to call it, illuminating engineering. Illuminating engineering. So, well, thank you for tuning in. Click the link below, which might take a couple of weeks for me to get around to putting it on there, but hey, if you enjoyed this, look at my other ramblings. Some of them are technical, some are not. But if you want to get an advanced chapter of or an advanced copy of the chapter on partial differential relaying and the analysis I went through to resolve a problem in our tripping a tripping problem on our switching station, follow the link, make the contribution, and that'll be released March of next year. Thank you for tuning in.